Well, what is Six Sigma? Now with Lean, we could solve most of our problems using a handful of Post-it notes to get people in a room using value stream mapping, spaghetti diagramming, or something like that to figure out how to make things better. But Six Sigma is really data-driven. We have to use numbers and counts and things to come up with ways to solve problems. And so we have the two sides of this coin. So on the one side is defects. Right? So there's a mistake somewhere. And there's deviation. Now in Six Sigma we talk about variation. You know, we want to reduce variation. But variation, I found, is such a benign term. I just call it deviation. Right? So we have delay, defects, and deviation. These two are some of the big demons in our problem-solving process. And so what we want to do in deviation is find ways that we have a target value and we want to produce a product that is right on that target line. Doesn't vary one way or the other. That's our goal in the world. Now with defects and deviation, we're going to start out with some sort of control chart that shows over time how are we performing. And from this, and the same thing in deviation, we want to see, well, here's, you know, how big our product is, and it varies like that. It has some control limits. So this shows us how our process is performing over time. Now with defects, we're going to go in and we're going to do a series of Pareto charts. And Pareto charts, we're looking for the big bar here. And we may actually have, you know, several layers of Pareto charts. We may have to take this thing down another level. Who knows? And then we're going to take this big bar and it becomes the head of our fishbone. And then we can start doing root cause analysis. And so defects, we're going to use control charts, Pareto charts, and fishbones to solve most of our problems. In deviation, obviously we've got a little variation going on here. Well, we're going to stand this thing up on its head and let all the points fall down, and that'll give us a histogram. And so we should have some data that looks like, you know, it's spread out a little bit, so on and so forth. So that's some variability, right? If our target value is here, and we've got some spread, and maybe we have some spec limits. Well, if we have a lower spec limit and an upper spec limit, we want all of this stuff to fit in here, and we want to find ways to reduce the variation, squeeze that down into the center, and make that a much higher bar. And again, we can use what we learn here to turn that into root cause analysis. So why are we having this variation? Well, it might be machine settings or you know, some sort of process thing. Everybody wants to blame it on employees and stop that, all right? The system, as Deming would say, causes 99% of the error. The system is forcing variation. The system is forcing defects. We want to fix the system, the process, the procedures, how we get stuff done. And when we do that, we're going to start to make dramatic improvements. Now, obviously, to draw these things, you're going to need some charts and graphs, and that's where the QI macros come in. So we can use different kinds of charts, like P charts and U charts and C charts to plot defects, categorize them with Pareto charts, and do fishbones. You're going to need the same sort of a chart, but in manufacturing, this might be an X chart or an X bar R chart, something like that. And then histograms and fishbone diagrams. And we'll dig into these all in more detail. But that's our problem-solving process. And again, we just want to get down to 0 defects. Right? Our goal in life is to drive this thing down. Our goal here is to tighten up the variation, so we want to have it so it sits in here and we get less variation around our target. We want to reduce this so that this becomes a big bar with not many sidebars there. And that's our goal. And we just keep doing this forever because machines get out of whack and things change and we get new production systems and blah, blah, blah. Right? So this is an ongoing process, not a one-time shot. You're not going to fix it all at one whack. Somewhere along the way it's going to come back to be a problem because somebody changed something or somebody forgot to sustain the improvement. The last thing we have to do at the end of this is we're going to have to put some sort of monitoring tool in place, a control chart, to monitor defects or deviation so that we make sure that we stay at the level we're at and keep getting better. As opposed to what normally happens is people declare victory here, they forget to monitor, and all of a sudden, pretty soon, we're back to crazy variation, and our defect rates go up. That's what we want to prevent. Sustaining the improvement is often the hardest part of this whole process. But that's Six Sigma. And when you do this, you can get dramatic reductions in defects and errors and waste and rework, and you can start to satisfy more customers, make more money, right? And not have all the warranty and returns and adjustment and all that other stuff that comes with defects and deviation. So learn how to use these tools. Be a money belt.